Hi everybody. In this tutorial I'm going to show you how to make a granular synthesizer using ofxMaxim for open frameworks. So let's begin with the first thing. Let's create a new sketch. Let's call it granular synth test. You can call it whatever you want. Go to add-ons, click on ofxMaxim, and let's generate our project. There we go. So let's go into first thing we need to do. I'm gonna play two samples in this tutorial. So I have actually just pre-copied them. So now we need to put them inside our data folder here so we can access them easily. Then just open it up. The normal ritual or cleaning this up. So let's see, we have, ooh, that's the wrong one. So we can look in our add-ons here to see that everything seems to be alright, which is good. I go back to this view that I prefer. You can just change it and make that a little bit smaller. And let's begin. So the first thing we always need to do, as I talked in the other tutorials, you need to include the H file. ofxMaxim.h. There we are. So, and the first thing we're going to do now is going to do a new thing that I haven't done before. We're going to do a type def, and we're going to set it to on win functor. We're going to call it grain player, like so. This will make us, we can actually use the grain player and play around with, it'll make a little bit more sense further on. And we do this outside of the class as well. So let's go and let's create our first, the normal audio out callback function that we use in the other tutorials as well. So let's call it void audio out. Takes three arguments, takes a float pointer, output, takes an int, buffer size, and take another int, and channels, which stands for the number of channels. There we are. Let's make it so. And then we want to create that buffer size, and we want to take the sample rate. Next thing we want to create is a double. We're going to call it samples. Sample and output. Outputs. And we're going to set that to an array of 2. And then we're going to create our samples, and we're going to use maxi sample like we used in the other tutorial, and we're going to call it samp2 because we're going to have 2 samples. I think that's not capital, it's going to be like that. Then we're going to create a vector of maxi time stretch. We're gonna use this. Now we're gonna use our grain player, and we're gonna set that to point. We're gonna do pointers and call it samples. So this is a vector of Maxi's time stretchers. We're gonna call it samples. We're gonna do a mixer. We call it maxi mix and call it my mix. Then we going to create these maxi time stretch, and we're going to fill it with grain player, and now we're going to do pointers. We're going to call them TS and TS2. So what this star says is that, yeah, you might know that it's a pointer we're creating. So now, and then we're going to set up our double, speed, and grain length. So these are actually the values that we're going to change, the variable we're going to change, because the speed is equal to the speed of the sample, and the grain length is, yeah, I'm going to show you, and you can, it's easy to see how, or hear what is happening when you change it. And then the last thing we're going to do is call it int and call it index. And index is the index of our samples. We're going to loop through the samples. I'm going to click the mouse and we're going to loop through the samples. And we're going to use the index to do that. And just a couple of more things, because I want to make it a bit clearer, or maybe make it more visual of what's actually happening with the samples when we use this synthesizer. So I'm going to use ofxMaxim FFT like we used in the other tutorial. And use ofxMaxim FFT octave and call it oct. So we're just gonna make something actually happening on the screen. So that is what we need in our .h file. So let's move over to our setup and set everything up. So first thing, this is a ritual, set up the sample rate and set it equal to 44,100, and then we do our buffer size, set it equal to, now I can see that I'm having error here. I think I misspell it correctly. Yeah, it should not be that. It should be like that. I think that should be it. Yes. Hopefully, we'll see. We'll see. I might need to debug this a little bit, but yeah. So we set our buffer size and our sample rate, and now we want to load our samples. So we do samp dot load of2 data path. So we do sound dot wav, and we're gonna do samp2, same procedure. Because I'm just using 2 samples, there's no need for me to loop through. But if you have multiple samples, you might want to use for loops to loop everything in and have them say sound 1, sound 2, sound 3, and etc. Data path, and we take sound 2 like that. And now we need to create. I can see I misspelled this. There we go. Now we need to create these. We did here the maxi time stretch. We call it a TS and TS2. And now we're gonna need to create these, because using pointers we need to use a very special word that, if you've done processing, you might be familiar with it, but it's called new. So we do new maxi time and here's a type name F, which is going to be our grain player. And then we do this. We need to use the ampersand, and then because what it means, this ampersand means that we actually this ampersand means is that it takes the address of what it's pointing to. So this is going to be our sample. I think I missed something, done something wrong here. Well, again, so I'm just going to do. There we go. Yeah. Terrible spelling. Sorry about that. And we're going to do the same thing for our TS2. So we're going to do new, not mu. ampersand samp2. So now we're pointing towards 2. Cool. And what we then need to do, we want to push these into our vector here of times of samples. So now we're going to use a, so we're going to do, see, I obviously cannot spell this word correctly. We're going to do samples dot push back, and we're going to do ts, and the same thing for the other one. Just because I'm just using 2 now in this, so if you have more than these, I recommend you to use for loops and loop everything in, because there's no point setting up everything manually. That's just not good programming. But for clarity, I'm just doing it really simple now for you guys. And now we're going to initialize our doubles here. Our speed is going to be equal to 1, which is going to be, so if speed is equal to 1, that is the normal speed of the sample. So that's going to be completely normal. So if you do -1, that means that the sample is going to play backwards. So you get a little bit of idea what speed actually does. So if I want to do speed 2, it's going to be twice as fast. So it's going to be really fast. So, and these are the things that we're going to change and play around with. And we're going to do grain length equals 0. Grain length takes much smaller numbers. And but yeah, you can play around with these however you want. It might be a cooler way, but I think this sounds pretty cool and it works for me. But you can try all of these numbers yourself. And we set index to 0, which is equal to 1. So that's going to be our first sample. So we're going to switch between the samples. We're going to change the index, and we're going to set up our FFT like we did in the other tutorial. FFT, and let's see if we can see what it says. No, I'm going to explain it. So yeah, FFT setup, it takes a FFT size. It's going to be 1024, and then it takes in the buffer size 512, and then it takes in the hop size, which is going to be 256. And then we're going to set up our oct.setup, and it takes in the sample rate is going to be 44100. You can use sample rate, the variable, but for clarity, let's just do it like this. Then we're going to need the number of bands. It's going to be 1024, sorry. And then we can take the number of averages per octave. We're going to set that to 10. Cool. And last but not least, we're going to do of sound stream setup, and it takes a number of arguments here for me. It takes a number of outputs. It's going to be 2. Number of inputs going to be 2 because we're using 2 samples. We're gonna point to this, and we're gonna do sample rate, and we're gonna use buffer size. I have to write it out. God damn it. There we go. Buffer size, and then we set the number of buffers, which is going to be 4. So what it does is switches on the DAC, so we can actually use this. So that is all that we need for the setup. So let's go down and create our audio out callback function. I'm going to be lazy now, so I don't want to write this out. So I'm just going to copy this, go to underneath draw here, do that, and also you need to do this. So if you do that, you cannot just put it like this. You need to have of app like so, because I've done this before and it took me a long time to debug what the hell was wrong with my code. Yeah, so there we are. First thing we have to do when we do something like this, we need to loop through our buffer size to be able to do anything in audio out. So we need to end I equals 0. I is less than buffer size I plus plus. So now we can actually do stuff in here. Cool. And let's set up our sample. So sample is going to equal to samples with an s on the end. This is maybe not the best variable to use, but anyway, in this I can change it now. So in here we're going to set index, so we're going to loop through our index of samples within our vector of samples, and we're going to use the magical arrow because we're using pointers now. So instead, if you don't use pointers, you normally do the dot. So you do samples index I dot play, because using pointers we need to use the arrow, so we're pointing towards that. We're going to use play, and play takes a couple of arguments, as you can see here. So it takes speed, which we already had. Oh look, we have the grain length also. Grain length, and then we're going to do 5, and then end up with a 0. You might want to change around these numbers as well, but for this tutorial, these numbers works fine, and this sounds good. So you can play around with this how much you want. And set up that. So that's our samples. This is gonna play all the samples that we have, but we need to do a couple of more things to make this work. So let's do a same thing we did when we played around with FFT. It's going to do FFT dot process sample, and then we're going to do oct dot calculate FFT dot magnitudes. So yeah, so if the FFT processes the sample, the oct here will calculate the magnitude of the FFT. So we just need that. The last thing we need to do is we're going to create our mixer that we created here in the .h file. So we're going to use my mix, and we're going to take in a sample and output, and we're going to do 0.5. So what 0.5 means is that this is the panning. So that's going to be in the middle. So if you want to just say if you're wearing headphones and you just want to play the sound in the left side, you do 1, and if you want to play on the right side, you do 2, and 0.5 means in the middle. Pretty straightforward. And let's do our output. So let's do output, same thing as before, number channels, let's say equal to output with an S on the end. 0 means left. I times n channels plus 1 equals outputs 1. That's left and right. And that is actually all that we need in our audio out. So let's move down. Before we my mix. Didn't like that. I missed something. Need to do that. Otherwise it won't play anything. There we go. Sorry about that. Because what I'm going to do, just for clarity, I'm going to move around these variables, the speed and the grain length, just using the mouse. So, but yeah, in a normal synthesizer, you might have like knobs and buttons to actually change these, so you can actually get like really. But just for show off, I'm just going to use the mouse. Okay. So what we're going to set up in mouse, you're going to do speed equal. You're going to have to call it like this. Double x, which is the x position of the mouse, divided by of get width times 4, and we're going to do minus. Like I said earlier, these numbers you can change around however you want. This is going to be, sorry, not going to be, there we go. So if you want, you can play around with these numbers. You can multiply it by more than or minus left, but these are the numbers that I found work really well for me. And I'm going to do grain length equals same thing, double, but then we do y. So the x position of the mouse is going to change the speed of the sound of the sample, and the grain length is going to be affected by moving my mouse up and down. So we're going to do of get height times 0.1. These are very small numbers here, but you're going to see why, because these don't want to be. I'm going to do plus 0, 0, 0, 1. So grain length take very small inputs, and like I said before, you can change these numbers if you want. Then we're going to go down here to mouse press or mouse pressed, and we're going to do an if statement saying that if plus index is greater than samples dot size minus 1, then do index equal 0. So if samples, I'm just going to loop it. So you get to 0, 1, go back to 0. Just reloop it. You can click how many times you want, and it won't throw an error. So just keep looping back. So technically this is gonna run if I've done everything correctly now. But I'm just let's do some visuals so we can see what we're actually doing, and it makes it a bit more fun. You can see how the FFT values changes depending on how I move my mouse. So we're just gonna make a really cool effect. So let's do it in background. Let's do in draw. Let's call our background and do of set color. Let's do just straight white. So background's gonna be black and everything in it's gonna be white. And like we did before, when I did the circle and in the FFT we saw that tutorial, we're gonna have to loop through our OCT and then get the number of averages. So we're gonna do OCT n averages dot I plus plus. So in here now we can do of rect. I'm gonna move it 100 pixels in. I'm gonna do I times 10. So these rectangles are gonna be spaced 10 pixels away from each other, and they're going to be 100 pixels in. And then I'm going to do of get height divided by 2. So you're going to start in the middle of the screen. And then we're going to set them to 5. So the width is going to be 5. So they're going to be quite small rectangles, and then so the length of the rectangle is going up, going to be affected by the FFT. So we're going to do minus oct dot. Now we're just going to do this. Oh, that's wrong. Sorry, the first one here, averages. Then we're going to do I times 2. So this will actually, what we can also do is that we can actually print out what the speed is and what the size is. Yeah, let's do that actually. Let's do that. Draw bitmap string. Let's do grain length. And where should we call it? Let's do it 100 pixels in, and do it of get height divided by 2 minus 100. Maybe not 100, let's do 50. So it's going to be 50 pixels underneath. And let's do of drop it, and let's do speed. And let's do it Let's do it 200 pixels in and use the same. There we are. So now, the first value is going to be just, you're going to see what the values are. And let's see, if I've done everything right, this will work, and we can see something. Oh, I have a backed access. Let's see. Let's see. Let's try it without that and see if it might be something else that I've done wrong. It's playing, but it's not the way I want it to play. Okay. Just delete all of this. Yeah, there's something wrong with my draw function. But now let's listen to it instead. This is the first sample. And let's, so if I move my mouse, and I'm moving now, I'm going to play it backwards. Yeah, it's really fun to play around with it. It sounds really cool, and depending on the samples that you have, you can get really cool sounds from it. So I would recommend you to play around with this yourself, and just find the samples that you like, play around with them, change the values of my variables, and see how that will affect the sound. And yeah, I hope that made it a little bit clearer what I'm actually trying to do. Sorry that the visuals thing didn't work, but I hope you enjoyed it. And thank you so much, and bye.